Hi, what is the value of k, given that you have k to the power of 6 equals 2 to the power of 6? So from here, let's have k to the power of 6. Let's take this to the other side as 2 minus 2, then 2 to the power of 6. Then let's set everything to be equal 0. So from here, let's have this k to the power of 3 and parentheses to the power of 2. 3 times 2 will give us 6, minus 2 to the power of 3 and parentheses to the power of 2. 3 times 2 will give us 6. Then let's set everything to be equal 0. Then the next thing is, this one has power 2, this one has power 2. When you have a square minus b square equals as when you have a plus b multiplied by a minus b. So when you equate this, we are going to have k to the power of 3 plus 2 to the power of 3 and parentheses multiplied by k to the power of 3 minus 2 to the power of 3, then equals 0. So from here, we have this to be equals this. For now, let's apply the product property law that says that when you have a multiplied by b that equals 0, this implies that it's either we have a equals 0 or we have b equals 0 for this expression to be equal 0. So let's say case 1, or let's say it's either we have k to the power of 3 plus 2 to the power of 3 equals 0, or we have k to the power of 3 minus 2 to the power of 3 equals 0 for this expression to be equal 0. Then from here, let's say case 1. So we are going to have here to be, let us recall from where we have a to the power of 3 plus b to the power of 3 that equals as a plus b in parentheses multiplied by a square minus ab plus b square as this. So when you apply it to this, we have k to the power of 3 plus 2 to the power of 3. Then we set it to be equal 0. When you apply it here, so we are going to have here to be k plus 2 in parentheses, then multiply by k square minus 2k. How do we get minus 2k? Our a is k, our b is 2. So here will be plus 2 square equals 0 from here. So from here, we have this to be k plus 2 in parentheses multiplied by, this will be k square minus 2k plus 4 in parentheses, then equals 0. Likewise, for this expression to be equal 0 as well, is either we have k plus 2 equals 0, or we have k square minus 2k plus 4 equals 0. So from here, we have the first solution to be k equals minus 2 as our first resolution. Then to obtain the second solution, we have k to be equals, by applying the quadratic formula, here will be minus b, positive or negative, roots of b square minus 4ac, then all divided by 2a. So from here we have k to be equals, now parameter b is the coefficient of k, which is minus 2. So definitely here is already minus. We have minus outside, so we have a minus 2, positive or negative. We have roots of minus 2 in parentheses to the power of 2 minus 4 multiplied by a is the coefficient of k square. C is the constant, which is 4. Then all divided by 2 multiplied by 1. So from here we have k to be equals to positive or negative roots of this square will be 4 minus 4 times 1 is 4. 4 times 4 is 16. So here will be 16 divided by 2. So we have k to be equals to positive or negative root of 4 minus 16 will be minus 12 divided by 2. And we can simplify this minus 12 further to be equals to positive or negative root of 12 times minus 1 divided by 2. So we have k to be equals to positive or negative root of 12 times root of minus 1 divided by 2. So let us recall that when we have root of minus 1 equals I in a complex number. So from here we have k to be equals to positive or negative root of 4 times 3 will give us 12 multiplied by I divided by 2. And so we have this as k will be equals to positive or negative. Root of 4 will give us 2. Then we have root of 3I divided by 2. So we have k to be equals this divided by this, 2 divided by 2, positive or negative root 2 multiplied by root 3I divided by 2. So from here we have k to be equals this and this we cancel, so we have 1, positive or negative. This and this we cancel, we also have root 3I. So therefore from here we have the first solution to be k equals minus 2. Then we also have k equals 1, positive or negative root 3I. So that is the first solution for case 1. So don't forget to share and subscribe for more. Like, comments. Then let's check for case 2. So for case 2, where we have k to the power of 3 minus 2 to the power of 3 equals 0. Let us recall that when you have a to the power of 3 minus b to the power of 3 always equals as when you have a minus b in parentheses, then multiply by a square, then plus ab plus b square. So applying it here, we are going to have k minus 2 in parentheses as this, then multiply by k square. Here will be plus 2k plus 2 square in parentheses equals 0 from above. So here will be k minus 2 multiplied by this will be k square plus 2k plus 2 square will be 4 equals 0. So for this expression to be equal 0, see that we have k minus 2 equals 0, or we have k square plus 2k plus 4 equals 0, which implies that from here we have k to be equals to as the first solution. Then likewise from here, we're going to have k to be equals minus b, positive or negative, square root of b square minus 4ac, then all divided by 2a. So from here we have k, b, coefficient of k, which is minus 2, positive or negative. Here will be 2 square minus 4 multiplied by a is 1, c is 4, then all divided by 2. So we have k to be equals minus 2, positive or negative, root of, here will be 4 minus 16 divided by 2. So we have k to be equals minus 2, positive or negative, root of minus 12 divided by 2. And we can simplify this furthermore to be minus 2, positive or negative, root of 12 times root of minus 1, all divided by 2. So from here, we have k to be equals 2, positive or negative, root of 4 times 3 times root of minus 1 divided by 2. But mind you, that when you have root of minus 1 equals I, a complex space. So we have k to be equals 2, positive or negative, root of 4 will give us 2, multiplied by root 3i divided by 2. So here is minus. So dividing 2 by 2, here will be k equals minus 2 divided by 2, positive or negative 2 multiplied by root 3i divided by 2, and k will be, this divided by this will be minus 1, positive or negative root 3i, where we also have another k to be equals 2. So if you are new here and find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more math tutorial videos. Bye bye.